Assalamu alaikum friends, this is Mohammad Inam, and in this video we are discussing about Clairaut's differential equation and D'Alembert's differential equation. Sometimes in some books it is called Lagrange also. So both are first order nonlinear differential equations. We can say that D'Alembert is the general case of Clairaut, or Clairaut is a particular case of D'Alembert's differential equation. So contents of the videos are general procedure for both examples and graph. If you like the video, then subscribe my channel. Okay friends, let's start the general procedure for Clairaut's differential equation. First we need to taking derivative with respect to x, then this will be y prime by multiplication rule, x y double prime plus y prime plus by chain rule f prime of y prime times y double prime. So we can cancel out y prime from both sides. The remaining part is x plus f prime of y prime whole time y double prime. So we can say that either y double prime equals to 0 or x plus f prime of y prime equals to 0. Here these are two cases. From here y prime equals to c, this will be the general solution or families of solution of Clairaut differential equation, and here we get the singular solution. What does mean by singular solution? A solution which does not belongs to the families of solution. That solution is called singular solution, and the relation between the families of solution and the singular solution is the families of solution will be the tangent line on this singular solution. So we have one example. Let's see that. So example is that y equals to x y prime plus cosine of y prime. So from the general procedure, we know we should first taking derivative with respect to x, that is y prime plus x y double prime minus sine y prime times sine y double prime. So again y prime from both sides cancel out, and here we have x minus sine y prime whole time y double prime. So y double prime equals to c 0, y double prime equals to 0, and x minus sine y prime equals to 0. So here equals to, from both cases we will try to find out what is y prime. So here y prime equals to c, then the general solution for this one, y equals to xc plus cosine of c. You can see that this is nothing but the families of straight lines. This is coincidence that always the general solution of Clairaut is just nothing but the straight lines. And what here, x equals to sine y prime, applying sine inverse both sides, then this is sine inverse of x equals to y prime. Here we get y prime equals to sine inverse of x. Applying here, y equals to x sine inverse of x plus cosine sine inverse of x. This is the singular solution, and this is its families of solution. What the graphical behavior of both is just like this one. If this is x and this is y, then this is this curve, and this all solution will be just like this one. Straight lines. Sorry for my drawing is not good, but you can see that all straight lines will be the tangent lines on this solution, on singular solution. For general procedure for D'Alembert differential equation, that is again differentiating with respect to x. First differentiating, let's assume that r equals to y prime. That is our assumption. So this differential equation will be look like y equals to x g of r plus f of r. Then differentiating, this will be y prime equals to, by chain rule or multiplication also, x g prime of r times r prime plus g of r plus this will be f prime of r times r prime, where r prime is nothing but the y double prime. So I can rewrite this y prime as r, or we can simplify r minus g of r, and this will be x g prime of r plus f prime of r whole r prime. Now this r prime means dr by dx. We can simplify this one. Say this is equation number 1. We can simplify this one as r minus g of r divided by x g prime of r plus f prime of r equals to dr by dx. If we invert this one, then this will be dx by dr equals to x g prime of r plus f prime of r and r minus g of r and r minus g of r. Now you can see that this is linear equation in x of r. Where you can find the x of r, then you can rewrite this one in terms of x. So this is the general procedure for the d'Alembert's differential equation. Here you can find the families of solution, but if you assume here that dr by dx equals to 0, then from this part you can find your singular solution also. Here we have one example. First I am rewriting y prime as r from general procedure. Now taking derivative with respect to x, this will be y prime and this will be x to r prime plus r square plus 2r r prime. Now this y prime rewriting as r, so this is r minus r squared 2xr plus 2r and r prime. So I am dividing 1r from both sides, then this will be 1 minus r and 2x plus 2r prime. Then now rewriting this one as dx by dr equals to 2x over 1 minus r plus 2 over 1 minus r. Now from integrating factor I found that x of r equals to c minus 1 over r minus 1 whole square plus 1, x of r. Now our task is to find the inverse of this function. So from here x minus 1 equals to c minus 1 over r minus 1 whole square. I can change this factor, then this will be r minus 1 whole square equals to c minus 1 over x minus 1. Now taking square root both sides, then this will be r minus 1 and plus minus radical c minus 1 over x minus 1. Now adding 1 both sides, then this is our r. This is our r. R means y prime, so y will be integrating plus minus square root c minus 1 over x minus 1 plus x, and this is our y general solution. And for singular solution we have to say that this part equals to 0. If r minus r square equals to 0, then it implies that r equals to 0 or r equals to 1. Here if y prime equals to 0, then y equals to 0. Y equals to some constant c, and here y prime equals to 1, then y equals to x plus c. Let's say c1, let's say c2, and these are two singular solutions, and this is the general solution of Lagrange differential equation. I hope if you like my video, so you can share your videos with your friends in circles on WhatsApp and other areas, and if you have any difficulty you can ask. Thank you so much for watching my video.